Hey everybody, so I'm still getting a ton of questions about counting atoms in a chemical formula. I don't know if they're really questions so much as they are people feeling frustrated and like they don't know how to do this. So I want to just make sure everybody knows that the best way to get help is to ask a specific question. Because if you ask a specific question, I can really quickly give you a specific answer about what you're confused about. But when I've just got, 10 people telling me, I don't get this, I'm confused, then I think, okay, well, I need to explain to the whole class. So I'm going to make a new explanation. So if you want like specific help, if you have something that's specifically confusing you, please make sure you're asking that question. Anyways, we're going to go through this today a little bit slower, and we'll talk about some of the things that may be getting you stuck and questions that you should ask if you are stuck. So, let's start by looking at this. How many atoms of carbon are in the reactants and the products? Well, there's one place we could be getting confused. What if we don't know what the reactants are and we don't know what the products are? Then we can't even answer the question. Well, this is from our notes last week. On Edpuzzle. If you'd like to go rewatch them, you can. If not, live your life. But basically, the reactants is going to be specifically the left side of the chemical equation. So that, what I just put a box around, I'll make it like orange or something so you can see it better. What I just put the orange box around is the reactants. Alright? Notice how, like, I wrote the reactants have blank atoms of carbon on the left-hand side, so you know it's the reactants. The products have blank atoms of carbon over on the right-hand side, so you know it was the products. Anyways, it just has to do with, like, where in the chemical formula it is. So, if you're on the other side of the arrow, or the equal sign, however it might be written, you're going to end up with the products. So, again, reactants right here, products right here. Now let's take a look at how many atoms of carbon are in the reactants. So we've been doing counting atoms, right? You guys are good at that. You did that last week. You did well on the quiz. I know you know how to do that. So all I'm asking you to do here is to look at each side of the chemical equation and count carbon separately on each side. So maybe some people are getting tripped up by the drawings underneath. You don't have to use those if those are confusing to you. It's just a way of visualizing what an atom of CO or O2 or CO2 might look like. And since we're not able to like build something in person to show us that, that's why those pictures are there. So let's take a look at how many atoms of carbon are going to be in the reactants. So ignoring the pictures for now, looking just at the molecules, doing counting atoms like we have been, I see I have a coefficient of 2 that's going to get multiplied to the C and to the O, right? Which means I end up with 2 atoms of carbon on the reactant side, because I have 2 times 1 is 2. Alright, now let's look at the product side. I see I have this coefficient of 2 already in blue, so I know it's separate. So I know it multiplies over to this C, and it multiplies over to this O. Alright, right now I'm concerned with the C, so I do 2 multiplied by C, and the products have 2 atoms of carbon, because 2 times 1 is 2. Alright, and if you need to visualize that, think about it as the black circles are carbon. Right here I have 1, 2 of those, and over on this side I have 1, 2 of those. Okay? Now let's move on to oxygen. How many atoms of oxygen are in the reactants? How many atoms of oxygen are in the products? Well, let's remember that reactants and products just mean the left and the right side of the equation, right? So I'm going to get our boxes so we know they're separate. And we know that right here, the left-hand side, the orange box, that is the reactants, okay? That is the reactants. Oops, I just made the whole thing orange. I just wanted to make the text orange. That is the reactants. And the red box is the products, right? Because the left-hand side, what starts off the reaction is called the reactants, and what you end up with, what you produce, is called the products. And now we're just going to do counting atoms like we have been doing. So the reactants, the orange box, have blank atoms of oxygen. Well, oxygen's right here. I see oxygen has no coefficient to worry about, only a subscript. Its subscript is 2, so that means that there are 2 atoms of oxygen. If I'm confused, oh, wait, I made a mistake. Cancel that. There's 2 atoms of oxygen right here. And I caught myself because I was looking at the picture, right? I was going to say, well, there's only 2 red circles, so there must only be 2 atoms of oxygen. But that's not right. There are 2 atoms of oxygen right here on this side, and we're going to have to add that 2 plus however many are over here to get total atoms of oxygen. So if I look right here, I do have a coefficient. My coefficient is 2. 2 multiplied by 1 is 2. So I'd get 2 plus 2 equals 4 atoms of oxygen. And I can confirm that by counting how many of the red circles there are. 1, 2, 3, 4. And that makes sense. Yep. Now let's look on the product side. On the product side, I see that there are 2 CO2, 2 carbon dioxide. So I've got a coefficient of 2, and I'm looking for oxygen. So I need to take my coefficient and make sure it gets multiplied by both. Right now I'm focused on the oxygen, but it does need to get multiplied by both. Take that, multiply it for the O2. So 2 multiplied by 2 is going to give me 4. And I can confirm that by looking at the picture. How many red circles are there? 1, 2, 3, 4. So again, you can do this just with atomic, like looking at counting atoms like we have been doing, and then you can confirm with the pictures if you're feeling confused. So, last question that goes with this formula. Does this equation follow the law of conservation of mass? In other words, is it balanced? So remember, what that means is there the same amount of atoms on each side of the equation? Is there the same amount of C in the reactants as there is in the products? Okay? So how much C is there in the reactants versus the products? Let's look. We solved that up here. The reactants have 2 atoms of carbon. The products have 2 atoms of carbon. So 2 and 2, right? 2 atoms of carbon on the reactants, 2 atoms of carbon on the products. We solved that. So carbon's balanced, right? Same amount of carbon on each side. What about oxygen? Well, I've got 4 atoms of oxygen on the left-hand side, 4 atoms of oxygen on the right-hand side, 4 and 4. That's balanced, so I did not create or destroy any oxygen. I did not create or destroy any carbon. I've got the same amount on both sides. On the reactants side, I've got 1, 2 black circles. On the products side, I've got 1, 2 black circles. Great, so that's balanced. What about red? I've got 1, 2, 3, 4. And on the product side, I've got 1, 2, 3, 4. So that's balanced. Again, when I'm looking to answer this question, if it follows the law of conservation of mass, all I want to see is if the atoms on the reactants and the product side are equal, right? Not if it looks exactly the same, not if it's still CO plus O2, but if there's still the same amount of carbon total and the same amount of oxygen total. I expect things to break apart from their normal compounds for those bonds to break and new ones to form. What we don't expect is to create or destroy any atoms. So if you're still feeling confused about this, please ask me for help. I want to help, but it's hard for me to know what you need until you ask me a specific question. So good luck. Reach out over Zoom, call, or text. Probably text, because the calls on Google Voice don't always go through to my phone. Or email if you need anything.